Here are the solutions for the Chapter 14 review. Number 1, use synthetic substitution to find the value of p of 3. List the coefficients down from polynomial p. So 2 from the x to the fourth, negative 5 from the x cubed, 5 from the x squared, negative 20 from the x term, negative 12 is the constant. Then make the synthetic division bracket. Next, divide in the value that you're supposed to input for p, which is 3, and follow through the process. 2, 6, 1, 3, 8, 24, 4, 12, and 0. This last number is the value of p of 3. Next, number 2. Let's redo the question, but this time use direct substitution. So if we want to find p of 3 with direct substitution, every time you see an x in the polynomial, you input a 3. So the first thing to do is to write it out with a 3 where the x is. Then evaluate this. You can do that by working it out mentally or typing it in the calculator. And the result is 0. Now we're using the same polynomial in number 1 and number 2, and we're substituting the same value. We have to get the same answer. So if you get different answers for question 1 and 2, then you need to go back and check your work on either 1 or 2. Number 3, use synthetic substitution to find p of negative 2i. So polynomial p is the same as it is in number 1. Write down the coefficients. 2, negative 5, 5, negative 20, and negative 12. This time when you're listing these down, you might leave a little more space between them, because we know from previous questions when you input something with I that it can create binomials. The number that we're substituting in is negative 2i. Bring down the 2. 2 times negative 2i is negative 4i. Now we have a real number and an imaginary term. So to add them, you really just write them side by side. Negative 5 times negative 2i is 10i. Negative 4i times negative 2i is positive 8i squared, but that's negative 8. So when you combine these together, this is 10i minus 3. 10i times negative 2i is negative 20i squared, but that makes 20. And negative 3 times negative 2i is positive 6i. When you combine these together, it makes 6i. 6i times negative 2i is negative 12i squared, but that makes positive 12. And adding these together, the result is 0. Again, this very last number is the value of p when inputting negative 2i. Next, number 4. Write out the coefficients as if we were going to do synthetic substitution, but don't actually substitute anything. So we have 2 from the x to the fourth. There is no x cubed, so that's a 0. Then we have negative 3 from the x squared. Then 5 from the x term, and the constant is 0. What I'm really asking you on number 4 is, do you recognize when polynomials are missing terms and you need placeholder zeros? Now number 5, rewrite polynomial p in this format. To do this, we're going to use synthetic substitution. So 2 from the x cubed, 3 from the x squared, negative 2 from the x, and then the 3. Divide in the value of r, which is 1, and run through the process. 2, 2, 5, 5, 3, 3, and 6. You're going to use these numbers here as coefficients in q of x. And this number on the end is going to be our value of p of r. So now what you do is you follow this format to rewrite the problem. It's x minus the value of r, which was 1. Now times polynomial q of x. So q of x is referring to a polynomial. And it is the depressed polynomial that we created right here. So it's 2x squared plus 5x plus 3. And then we have a plus sign, and it says P of R. P of R is this last number that we got, 6. So right here is the answer in the format that we were asked for in the directions. Number 6, we want to do a division of polynomials and use synthetic division, which you can use as long as you're dividing by a linear binomial. It has to be a linear binomial that you're dividing by, or you can't use synthetic division. You'll have to use long division. So write down the coefficients. 2 from the x cubed, then negative 7, then negative 17, and then 10. Divide in the number that is subtracted from x, which is a 5. If this had said x plus 5, then the number you're dividing in would be negative 5. You're dividing in the 0 of that factor. What number for x makes this be 0? It would be a 5. Now run through the process. 2, 10, 3, 15, negative 2, negative 10, 0. We're doing division. This number that you get on the end is your remainder. A remainder of 0 means that it divided evenly. These right here create a polynomial. They are the coefficients of a polynomial. The polynomial is a depressed polynomial, meaning if the original one was to the 3rd power, this one is to the 2nd power. So what do we get when we divide? We get the answer 2x squared plus 3x minus 2. If the remainder was something other than 0, then on the end you would say plus, and you would write the remainder over the divisor x minus 5. For example, let's say we got all done, and this turned out to be a 7 right here. So we would have the same start to our answer, and then on the end we would say plus 7 over the x minus 5. That last thing is how you show a remainder. But in our question, that wasn't it. So here is the answer. Now number 7, it is the same question, but using the long division process from earlier this year. We have to get the same answer in 7 as we did in 6. So look at the leading term and look at this leading term. X times what makes 2x cubed? That would be 2x squared. 2x squared times x is 2x cubed. 2x squared times negative 5 is negative 10x squared. Now subtract. Negative 7x squared subtract negative 10x squared is 3x squared. Earlier this year, you might remember I cautioned you about subtracting. To use a calculator if you're not confident about it. Negative 7 subtract negative 10 is what you would type in. Now bring down the next term. Now look at the leading thing, x, and look at this leading thing, 3x squared. X times what is 3x squared? That makes positive 3x. 3x times x is 3x squared. 3x times negative 5 is negative 15x. Now subtract. It's negative 2x. Bring down the 10. X times what is negative 2x? Well, that would be negative 2. Negative 2 times x is negative 2x. And negative 2 times negative 5 is positive 10. Now subtract. 10 take away 10 is a remainder of 0. Right up above here is the answer. Let me repeat what I said in number 6. If you get some number that's not a 0, then to show the remainder, on the end of this answer you would write plus, and you would write down that remainder number on top of the thing you divided by, which is the x minus 5. Number 8, use synthetic division to show that x minus 3 is a factor of this polynomial. Let's use the coefficients, 2, negative 11, 12, and 9. Now think about what number you're going to divide in there if you want to test if x minus 3 is a factor. You would want to use 3. Because 3 is the number that you would put in for x so that that factor becomes a 0. Well, let's substitute 3 in and see if we get a 0 at the end. So bring down the 2. This is 6, negative 5, negative 15, negative 3, negative 9, and 0. Because we got 0, that's why the answer is yes, that it is a factor. If the remainder is not 0 when you divide something in, then the thing that you were checking is not a factor. Next, number 9. Use synthetic substitution to show that x equals 5 is a root. This is exactly the same skill that we just did. Write down the coefficients. 1 from the x to the 4th, negative 16 x cubed, 86 from the x squared, negative 176, and then 105. The number that we're checking is 5. We want to know, when we use 5, do we get a 0? Let's run through the process. 1, 5, negative 11, negative 55, 31, 155, negative 21, negative 105, and this does make 0. So our answer is yes. Now number 10, solve each equation by finding all of the roots. And the hint is to start with synthetic substitution because it goes to the 3rd power. Once you've depressed to a quadratic, then use the traditional methods such as factoring or quadratic formula. So let's write out our coefficients. 1, then negative 1, negative 14, and 24. Now we want to take a guess at what number might divide in there so that there's a remainder of 0. There is a test that you can perform to think about possibilities. It involves looking at the last number and at the leading coefficient. What are the factors of 24? They're things like 1 and negative 1, 2 and negative 2, 3 and negative 3, 4 and negative 4, and so on. All the numbers that divide into 24. Well, you just got to choose something to start with. Maybe 1 works. 1, 1, 0, 0, negative 14, negative 14, 10. 1 is not a root because it didn't make a 0. So we have to erase that and try something different. We might try 2. 1, 2, 1, 2, negative 12, negative 24, and 0. So because we got a remainder of 0, 2 is a root. Now we're not done yet. Take this, this, and this and use it as coefficients on a depressed polynomial. So 1x squared plus 1x and then minus 12. Set that equal to 0 and think about how to solve it. This one does factor as x plus 4 times x minus 3. Solving in the first parentheses, we find out that x equals negative 4 is a root. And in the second parentheses, x equals 3 is a root. So over here on the side, let's write the answers down. 2 works, negative 4 works, and 3 works. Here are the 3 roots. And we expected 3 roots because it went to the 3rd power. Now number 11, here's another equation to solve. We're going to use exactly the same technique. This time we're expecting to get 4 answers. So let's start with synthetic substitution. 1, negative 8, 14, 8, negative 15. And you just got to pick something to start with. Just make sure you're picking something that's a factor of this last number, like 1, 3, 5, 15, something like that. I'm going to try 1. So 1, 1, negative 7, 7. This is 7, this is 15, this is 15, and it makes 0. So 1 is a root. Now, we don't have this depressed all the way to a quadratic yet, Because if you start to the fourth power and you do synthetic substitution one time, you've depressed it to the third power. So let's do synthetic substitution again on those four numbers. We want to pick something else to substitute in. I'm going to try -1, just see what happens. 1, -1, -8, 8, 15, -15, and 0. We got 0, so -1 is a root. And we've now depressed our polynomial enough that we can use those three numbers to write in polynomial form. 1x squared minus 8x plus 15. Now set that equal to 0 and think about how to solve it. Does it factor? Are there two numbers that times to 15 and add up to 8? There are. So x minus 5 times x minus 3. In the first parentheses, x equals 5 is the answer. In this parentheses, x equals 3 is the answer. So over here on the side, let's write down our four roots. 1 was the first one. -1 was the next one that we found. 5 and then 3. Here are the four answers. Number 12, according to the fundamental theorem of algebra, how many roots does the following equation have? The fundamental theorem says that whatever the degree is, that's how many roots. So the highest exponent is 11. This has 11 roots. Number 13, given one root of an equation is the complex number 3 plus 2i. What's another root? There's a theorem that says if you have a complex root, then its conjugate is also a root. So we really want the conjugate of this number. That's 3 minus 2i. When you do a conjugate, you're not changing the real number term. You're only changing the sign in front of the imaginary term. Now, number 14, factor this completely. This is not one of the factor patterns that we recognized from earlier this year. It's not a trinomial that you use FOIL. It doesn't have a GCF. It's not a difference of squares. It's none of those things. So to do this, let's start with synthetic division. 1 from the x cubed, 0x squared, -8, positive 3. Let's try a number in there, maybe 1. So bring down the 1, 1, 1, 1, -7, -7, -4. It did not make 0, so 1 is not a root. If 1 is not a root, then x minus 1 is not a factor. Let's erase that and try a different number. I'm going to try 3. 1, 3, 3, 9, 1, 3, 6. Nope, still didn't get 0 at the end. So 3 is not a root of the original equation. Therefore, x minus 3 is not a factor. Let's try -3. 1, -3, -3, 9, 1, -3, 0. Hey, we got a 0 finally. What that means is, if this was an equation, if this said equals 0, then the root is -3. We're not solving an equation though, we're trying to factor it. So if -3 works, then a factor is x plus 3. And by doing synthetic substitution, we have depressed our polynomial. So we can use these three numbers as coefficients. We have 1x squared minus 3x plus 1. Now let's factor this. First of all, can you use FOIL? Are there two numbers that multiply up to 1 and they add up to -3? There aren't. So now we're going to use completing the square. Let's just rewrite it and just move the +1 over a little bit to create a blank spot. We're now going to fill that blank spot in with a number. Here's how you get the number. You take half of this and square it. So half of -3 is -3 over 2. Squaring that is positive 9 over 4. Now when you fill in 9/4, you have to compensate by subtracting 9/4. Next up, These three terms right here are now a perfect square trinomial, and it factors as x minus 3/2 squared. Then these two constants can be combined together because they're like terms. That makes negative 5/4. The reason for doing that is we've now made a difference of squares, and we know how to factor a difference of squares. Two sets of parentheses, and in the parentheses, it's the square root of the first term. So x minus 3/2 goes here, and it goes over here. We're just not used to it being so complicated. We're used to our difference of squares being something simple, such as like just x squared minus 9. So when you do the double parentheses, you're just going like x and x. We're using the same idea, it's just we have x minus 3, which was squared. So we're going x minus 3/2 and x minus 3/2. Then there's a plus sign, and over here a minus sign. Now in this spot, use the square root of 5/4. That's the square root of 5/2. Again, this is exactly the same thing as what we're used to from earlier in the year. So if you look over at this one, what's the square root of 9? We would write plus 3 and minus 3. Same idea. We have just found two more factors. So I had started to write my answer up here. We just need to finish it off. So another factor is x minus 3/2 plus the square root of 5/2. And a third factor is x minus 3/2 minus the square root of 5/2. Here is factored form.